Hello class, taking a look at the backside of our two-step equations practice. Taking a look at question E, we want to start by drawing our wall. And these ones are a little bit more complicated just because they have some weirder things going on with their integers and their negatives and things. But like always, we're going to draw our wall. We're going to draw our x's first. So I got plus 2x, that's 2 positive x's. And I also have 3 negative constants on that right side. On the left side, I have 7 positives, and I'm going to sort those into their 2 rows. 6, 7. In terms of solving this equation, I need to get my x's by themselves. Right now, they are being bothered by these 3 negative constants, so what cancels with those is 3 extra positive constants. If I place 3 extra positive constants on the right side, I must also place 3 extra positives on the left. Splitting up our rows fairly, we can see that that x is matching to 5, and that x is also matching to 5. We can say our solution is 5 is equal to x. In terms of our symbolic work, we want to think about what is being done to our x. Our x is being multiplied by 2. That's pretty easy with a coefficient of 2 there. We're also being added by minus 3. And remember that adding a negative is like subtracting. So you could rewrite this as 2x subtract 3, and that would mean the same thing. The other way that we can think about it is we need to do something to cancel with minus 3. So what's the opposite of minus 3? Well, it is plus 3. Of course, we do that to both sides. Minus 3 and plus 3 cancel out, leaving us with just 2x on the right side. On the left side, 7 plus 3 is 10. Again, it can help to think about the pictorial work here. Of course, we had to add 3 positives to cancel out with the existing negatives, and that's why we're adding 3 here as well. Okay. From this point, we want to undo the multiplication by 2. So 2x means 2 multiplied by x. The opposite of multiplying by 2 is dividing by 2, and we'll divide both sides by 2. 2 cancels with 2, leaving us with just x on the right, and 10 divided by 2 is 5 on the left. In terms of our verification, our original left side was 7, our original right side was negative 3 plus 2 times whatever x is. We think that x is 5, and we're going to do this calculation. Negative 3 plus 2 times 5 is 10. Now remember, when you add integers, you're going to subtract the numbers if they have different signs. So negative, positive, we do have different signs. 10 take away 3 is 7. And we keep the sign of the bigger integer. 10 is bigger, and it was positive. So is 7 equal to positive 7? Yes, it is. And then our left side does equal our right side. In terms of question F, again, we're going to start by drawing our wall. We're going to draw our 2 x's and our negative 8, or 8 negatives. 3, 4, 5, 6, 7, 8 negatives. On the other side, we're going to draw our 2 negatives. Okay, and 2 rows with the x's. I need to get rid of the constants that are with the x's, so that is all of these constants here. So what cancels with 8 negatives is 8 positives. 4, 5, 6, 7, 8. Cross out my 0 pairs. And of course, I'm going to add 8 total to this side. 1, 2, 3, 4, 5, 6, 7, 8. I'll cross out my 0 pairs there as well. Last thing to do is circle my x's. So this x matches to 3, and this x matches to 3 as well. And so I can say that a single x is worth 3 positives. In terms of my symbolic work, the opposite of subtracting 8 is adding 8. Of course, I'll do that to both sides. Minus 8 and plus 8 cancel out, leaving us with just 2x on the left side. And then we have to be careful with our integers. Starting at minus 2 and going up by 8 is going to bring us to positive 6, or just 6. Again, you can use a rule. When you add integers with different signs, subtract the numbers. 8 take away 2 is 6. And then keep the sign of the bigger one. The bigger one was positive. And of course, positive 6 is the same as just 6. Last thing to undo is multiplication and division. 2x means multiplying x by 2. The opposite of multiplying by 2 is dividing by 2. And we'll divide both sides by 2. 2 divided by 2 is 1, so 1x is just x, and then 6 divided by 2 is 3. In terms of our verification, we have 2 times whatever x is, subtract 8, should give us negative 2. We think that x is 3, so 2 times 3, subtract 8. 2 times 3 is 6, and 6 subtract 8 is negative 2. Negative 2 is the same as negative 2, so the left side does equal the right side. Question G, we're going to start with our wall and our 2 x's. We also have 5 negative constants over here. And on the other side, we have 3 positives. We're going to cancel out our 5 negatives with 5 positives. And we'll do the same to the other side. 2, 3, 4, 5. Split up your rows. X is 4. And then we can do our symbolic work. So here's our x. It is being added to that. We are adding negative 5. So what's the opposite of negative 5, or what would cancel with minus 5, is plus 5. And we'll do that to both sides of the wall. Minus 5 and plus 5 cancel out, leaving us with our 2x, black. And on the other side, 3 plus 5 is 8. 2x means multiplying x by 2. The opposite of multiplying by 2 is dividing by 2. 2 cancels with 2, leaving us with x. And 8 divided by 2 is 4. In terms of our verification, we're going to go ahead and do our original left side with negative 5 plus 2 times whatever x is. Original right side was 3. We think that x is the number 4. So we're going to do negative 5 plus 2 times 4. 2 times 4 is 8. And negative 5 plus 8 is adding integers with different signs. When we do that, we subtract the numbers, so 8 take away 5 is 3, and we keep the sign of the bigger one. 8 was bigger, and it was positive. Positive 3 is equal to 3, so the left side does equal the right side. Last one here, again, we'll start with our wall and our 2 x's. Okay, we also have 5 positives. And on the other side, we've got our 7 positives in our 2 rows. 7. Need to cancel out the constants that are with the x's. So I need to cancel out these 5 positives by placing 5 extra negatives. I'm going to place 5 negatives on the other side as well. 4, 5. I'm going to finish up by circling my rows. So this x is worth 1, and this x is worth 1. So I can say that 1 is the value of x. Okay, finishing up in terms of my solving steps. Here's my x, and it's being added by 5. The opposite of adding 5 is subtracting 5, which we'll do to both sides. Positive 5 and minus 5 cancel out, leaving us with 2x on the right side. On left side, 7 take away 5 is 2. Last thing to undo is the multiplication by 2. 2x means multiplying x by 2. The opposite of multiplying by 2 is dividing by 2, so we'll divide both sides by 2. And I guess we should get actually 1 equals x, but of course x equals 1 means the same thing. In terms of our left side and right side verification, our original left side was 7, our original right side was 5 plus 2 times whatever x is. We think that x is 1, 2 times 1 is 2, and 2 plus 5 is 7. Since the left side was 7, the left side does equal the right side, and our solution is verified. So those questions are a little bit more complicated with some of those integers there, but still not too bad. Just follow your steps.